Now that we've explored how to represent relationships between events, let's shift our focus to the probability of an event itself. The probability of an event, written as PE here, tells us how likely that event is to occur. It can be expressed as a fraction, decimal, or even as percentage. There are a few basic rules we must always remember. The probability of an event lies between 0 and 1, inclusive. If an event cannot occur, its probability is 0. If an event is certain, then the probability is 1. The sum of all probabilities of all outcomes in the sample space is always 1. These rules form the foundation of all probability calculations, simple yet powerful. Next, let's explore the three main interpretations of probability which help us to understand how probability is applied in different contexts. Probability can be interpreted in three ways: classical, empirical, and subjective. Each interpretation gives us a slightly different perspective on how we estimate the likelihood of an event. The classical interpretation of probability is one that we must first learn. It assumes that all outcomes in the sample space are equally likely to occur. For example, when rolling a fair die, each of the 6 sides has an equal probability of 1/6. The formula for classical probability is simple, as we can see here. This is where the number of outcomes in the event is divided by the total number of outcomes in the sample space. This method works perfectly for well-defined control experiments like games of chance, but not as well when real-world uncertainty or unequal likelihoods are involved. Next, let's see how probability works when we base it on actual data and observation. The empirical interpretation of probability relies on observed data rather than assumptions. It is based on what actually happens in repeated trials or experiments. For example, if hospital records show how many days maternity patients stay, we can use the data to estimate the probabilities. This approach is often used in business, research, and science, anywhere we can collect data from repeated observations. Now let's take a look at an example to make this clearer. Here's an example using hospital data. Hospital records indicate the number of days patients stay. Let's calculate a few probabilities. We find the probabilities of a patient stay exactly 5 days. This is by taking the frequency of the 5 days divided by the total of frequency. We have patients stayed less than 6 days, so the probability is taking 15 plus 32 plus 56 divided by the total frequency. And lastly, we have probability of patient stayed at most 4 days, so we are taking the 15 plus 32 divided by 127. So you have the probabilities by taking into account the frequencies divided by the total frequencies. The third interpretation is subjective probability, and as the name suggests, is based on personal judgment or estimation. This type of probability doesn't rely on data or equal outcomes, but on experience, intuition, or expertise. For example, a physician might say, based on my diagnosis, there's a 30% chance the patient will need surgery. Or a business analyst might estimate a 60% chance of market growth next quarter. Subjective probability is widely used when data is scarce or uncertainty is high. It allows experts to make informed decisions using their knowledge.